Hello everyone. In this lecture, I will focus on decimal or base 10 to a general base R conversion. So, first step for this conversion is to separate the decimal number into integer and fraction part. So, suppose if the number given is 89.64 to the base 10, you have to write it like 89 plus 0.64. So, separate the number in integer and fractional part. Now, to convert this integer part in base R, okay, that means for integer part, what we have to do? We have to divide the number. Divide the number means this decimal number and all its successive quotient by the required base R and accumulate the remainder. So this will be more clear when I will explain it using an example. So suppose the number given to me is 153 in base 10 and I want to convert it in base 8. Okay, so what I have to do, and here it is only integer part, so there is no need to separate it in integer and fraction. It is totally integer part. Okay, so what I have to do? So number given is 153. You have to divide this by the base. Okay, here I will write remainder, here I will write quotient. So when I divide 153 by 8, the quotient will be 19 and remainder will be 1. So you can do one more thing, you can write remainder here also, no issue. Fine. So what I have, because see it is like 18, not 18, see 19 into 8 plus 1, it is nothing but 153. So this is the quotient I write here, and this plus 1 is remainder which comes here. Fine. So now again this is the remainder, sorry, this is the quotient. Okay, so now this is the quotient. So I will divide this quotient again by base R. So 8 2 ja 16. So remainder will be 3. Fine. So here what I am getting, this 19 is nothing but 2 into 8 plus 3. So 2 is the quotient and 3 is the remainder. Again I will divide this 2 by 8. So obviously this 2 cannot be divided by 8. So quotient will be 0 and remainder will be 2. Okay, see in my step I told to accumulate remainder. So these are the remainder, right? These are remainders. These are remainders. So we have to write these remainders, and these remainders will give me that converted number. Okay, so and here you have to see this will be a naught coefficient, this will be for, or first remainder will be a naught, second remainder will be a1, third remainder will be a2, likewise. Or we can say this one will be MSB and this one will be LSB. Okay, so you know this is a0, a1, a2. Or second thing that we can say it, now write this number like this. Okay, go from bottom to top, go from bottom to top means a2, a1, a0. Okay, so what is that? That number is nothing but 2 3 1 and base will be 8. So 153 to the base 10 is nothing but 231 to the base 8. Now if you want, you can check this using the other conversion system. You can check this whether 231 in base 8 is same to 153 in base 10 or not. use the previous method. So let me check this. 231 in base 8. What it will be in base 10? In base 10 it will be 2 into 8 raised to power 2, because this is place 0, place 1, place 2, right? Plus 3 into 8 plus 1 into 8 raised to power 0. Here it will be 1. Okay, so this is nothing but 2 into 64 plus 3 into 8 plus 1, and this is nothing but 128 plus 24 plus 1, and if you see it is nothing but 8 2 12 and 13, so this will be 3 5 and 1, right? So I can see this 231 in base 8 is same as 153 in base 10. So what we have to do, just to convert decimal to base r, what we have to do, divide the number by base and divide the successive quotient and collect all the remainders. Now the remainders should be written like from bottom to top, from bottom to top, or this will be MSB. MSB is most significant bit, and this will be LSB, which is least significant bit. Now about LSB MSB, if any number is like this, suppose if I have a number 2468, then this 8 will be LSB and this 2 will be MSB. We call this LSB because this is least significant bit and this is most significant bit. So this is least significant bit and this one is most significant bit. Okay, this is most significant bit. And why we call it least significant and most significant? Because see, this 8 contribute to only 8, and suppose this is in base 10, suppose this is in base 10, so this 8 will contribute overall to 8 into 10 raised to power 0, which is nothing but 8 only. But this 2 will contribute like 2 into 10 raised to power 0, 1, 2 and 3. Okay, 2 raised to power 3, that is 2000. So this is contributing maximum to this whole number. So we call this least most significant bit and this as least significant bit. Okay, so let me give you one more example. So suppose I have this number 41 in base 10. I want to convert it in base 2. So what I should do? I have to divide 41. So make a table like this. 41 here. Here I will write remainders, right? And I will divide this, correct? So I will divide this by the base and required base. I will divide by required base. Required base here is 2. So 41 will be divided by 2. So 2, it will go 20 times and remainder will be 1. Again I can divide this to 20 by 2. Quotient will be 10, remainder will be 0. Again I will divide by 2 and I will keep on this division unless and until my quotient is 0. Again it will be 5, quotient is 5, remainder is 0. Okay, it is like, see, 2 into 20 plus 1, 41. 2 into 10 plus 0 is 20. Then again I will divide it by 2. So 2 2s are 4 plus 1. So remainder will be 1, right? Again I will divide it by 2. So 2 1s are 2. Remainder will be 0. Again divide it by 2. 2 and 1 cannot be divided by 2. So quotient will be 0. Remainder will be 1. Fine. Now, so to write the number, just remember this one is MSB, this one is LSB, or you can use move like this to write the number. So move like this means 1 0 1 0 0 1. So number will be nothing but 1 0 1 0 0 1 to the base 2. So 41 in base 2 is nothing but 101 001 in base 2. Now you can verify it whether it is 41 in base 10 or not using that any number system to decimal number system conversion. Next will be how to convert fractional part into fractional part of decimal into any other base. Okay, so second is means for fractional part, what we have to do for fractional part? For fractional part, we will multiply the fraction with required base and accumulate the integer part of the result. Okay, so here also successive multiplication will be done. Like if you multiply a fraction by the required base, it will give you some number, and that number will have integer part and fraction part. So here we will separate integer part and fraction part, and integer part will be accumulated and fractional part will be multiplied again and again with the same base. Okay, so it is also a repetitive process. And let me give you an example. Suppose I have 0.75 in base 10. What will be this in base 2? Okay, so what we have to do here? So the number in base 10 is 0.75 and required base is 2. So here we will multiply this number by required base and separate the integer part and fractional part and multiply the fractional part again and again until we get a total integer part or up to some 3 or 4 digit. Okay, so let me solve this. So here number is 0.75, so multiply it 0.75, multiply it by the required base. Answer is, so 0.75 into 2, it is nothing but 1.5, right? So I can write it like this, 1 plus 0.5. Okay, so this is integer part and this is fraction part. Fine. So again multiply this fractional part. So this fractional part, multiply it by required base, so it will be 1. So what I have, 1 plus 0.0, correct? So here it is nothing but, now we have to accumulate this integer part, and here we will move like this, here we will move like this. Okay, so this will be nothing but 1 in base 2, and since it is fractional, so 0.11 base 2. Now let me give you one more example. So suppose my example, I will use that only. Suppose this example is this 0.513 to the base 10. What will be this in base 8? Now for this, what I have to do? We have to multiply this 0.513 by required base, which is 8. So this will be something 4.104. So it can be written like 4 plus 0.104. Okay, this 4 is integer part, this one is fractional part. Now again what we will do, again we will multiply this fractional part 0.104 by the required base, which is 8. So this will be something like 0.832. so this can be written like integer here is 0 and fractional part will be 0.832. again multiply 0.832 by 8, it will be something 6.556. so this is nothing but 6 plus 0.556, and it will goes on like this. Okay, so and here what I said, we have to move like this, right? So the answer will be 0.406 to the base 8, correct? So this way we can convert decimal number system to any number system. Okay, now suppose if I ask you this question, if I gave you question like this, here what I have given, here I have used 231, right? First problem was 231, no sorry, it is 153 in base 10, right? 153. So suppose if I gave you 153.513 in base 10, it is nothing but, so I have already calculated 153, right? And what was 153? 153 was 231. Okay, 153 was 231. Point 5.513 is 0.513 is nothing but 406. So 153.513 in base 10 is nothing but 231.406 in base 8. So this way we can calculate any this decimal number system to any base number system. And this is all about the conversion. If you have any doubt, feel free to ask me. Thank you.